Hey, good day, AP students and other students. Today we're going to discuss standard deviation and standard error. Now, every time we do labs and collect data, you're going to be doing standard deviation and standard error. It's important that we learn how to manipulate the data. Right? So, standard deviation is going to tell you how good your data is, and so is standard error. So, let's take a look at what we're doing here. So, in standard deviation, we're going to look at how tight or spread out our data is in each lab. The standard deviation is the square root of the variance. What is the variance? The variance is the average of the squared difference from the mean. And the mean is the average. Right, so we're going to go over the steps to calculate standard deviation. And hopefully you get all this stuff down. Remember to hit pause, whatever, when you need to. So in step one, you're going to calculate the mean or the average of all your data. Let's say that we're going to calculate the standard deviation of the heights of 6 different dogs. So we have 6 different dogs here, right? We'll put them in order from lowest to highest, from 250 millimeters to 900 millimeters. The mean is the average, so we add them up and divide by the number of dogs, which is, add them up, we get 3,695 millimeters divided by 6 dogs equals 616 millimeters per dog. All right, we're good? Questions? So then we're going to subtract the mean from each set of data points. Now this could be getting long and drawn out, I know, and there are actually programs on the calculators. So I think a TI-84s, TI-82s. I think there is actually a standard deviation, but we're going to learn how to do it by hand for a couple times, then we can rely on technology. So we take 616 as the average or the mean, and we're going to take everyone, we're going to subtract it. All right, so 720 minus 616, 625 minus 616, all the way down. All right, good? Yeah? All right. Now we're going to take the square of each of the differences. So we took this as 104 difference, take the square, that's 10,816. 9 squared is 81, and so on. You're going to need a definite calculator for this one. All right. So step 4, you're going to find the mean of the squared differences, which means you're going to add them up and divide by 6, which is 57,520. We take the square root of the mean of the squared differences. So the square root of 57,520, I have problems with that, equals 240 millimeters. So that is the standard deviation of that's one standard deviation. Now, how many dogs fit within one standard deviation? If the mean is 616 and one standard deviation is 240, we're talking about a range of 856 to 376. So standard deviation goes at the mean. So 4 of the 6 dogs fit within one standard deviation of the mean. How many dogs fit into 2 standard deviations of the mean? Well, they pretty much all should. All right, but good. And we're going to give you some problems later on so that you can practice this and we'll be good. So you get all steps. So we get step 1, calculate the average. Step 2, subtract the mean from each data points. Step 3, square each difference. Step 4, find the mean of the square differences, and then take the square root of the square differences. That's a lot. AP Stat, here we come. Now the standard error is you take the standard error deviation value and divide it by the square root of the sample size. All right, so the last thing you calculated in the standard deviation calculations, and then divided by the square root of the sample's size. So in our data, we had 6 data points, and the square root of 6 is 2.45. The standard error is 240, so we divide 240 by 2.45, and that's 97.96. We subtract the standard error from the mean. That's 518.04, and then add the standard error to the mean, which is 713.96. And those are your whisker bars. Those are your whisker lines coming from the mean. I don't know if you've ever seen graphs, but we have the point, and we have a line coming up and a line coming down. Those are the standard error bars. And we don't want to see overlapping standard error bars, because if there are overlapping standard error bars, then that means our data really isn't all that significant. So here's a range of test scores for the class. Hopefully you will not get the 50 and 42. If you're raising your hand or thinking to yourself, that's going to be me, we need to talk. So calculate the standard deviation of these scores. Let's follow the steps. Your total, that's your average, that's your difference, right? And we take the square of the differences, we take the average. Good. Okay, so maybe we shouldn't look at those answers, but there we go. And then we should be able to do a bar graph with the whisker bars coming up and down. Hopefully that helped. We're going to be doing this again for every single lab that we do in which we calculate data. You'll be experts about this after a while. It's crazy, but it's got to be done. All right. So this is Mr. Worski, and let's get calculating. Oh, this is going to be so much fun. Oh, I got to love it.